Okay, so we've got question 5 that asks about a line of charge along kind of half a semicircle, quarter circle, with a and it wants to go field. And if you go through it and find each charge point, it will have a force moving towards the center, and it will all together they will end up with electrical force in the y direction, and you sum them, and in the x direction. And so to find those, you'll need to integrate, and you'll be left with the total electrical force in the in this direction up here.
Okay, so first off, with all these problems, you always start off with this equation here: E is equal to K times your delta Q over R squared, just your normal equation. Since this is a line charge, you can use lambda is equal to Q over L. And then our L, since our L is going to be this distance here, and that's going to be, for an entire circle, it'd be pi times D. But since it's a quarter circle, we can do pi halves times R. And so then if you solve this for delta Q is equal to lambda times R times delta theta, that's what your delta Q is going to be. So if you put this back in here, you can find that delta Q is equal to Q over pi halves R times delta theta. Your R's actually cancel. So now we can integrate this for E of X and E of Y. And to get it in the X direction, we'll just do the cosine of this theta at any point will give us the X direction, and then the sine of theta, everything the Y direction. So that'll look something like this. E of X will be equal to our K times Q over pi halves times R squared. That's just coming from this equation over here. And then we have our delta lambda or delta theta. We'll have to integrate. And I'm just going to integrate from pi to negative pi halves. You can do from 0 to pi halves or pi to 3 pi halves. It's all the same as long as the length. So negative pi halves, and then this is going to be pi. And for the x direction, it's going to be cosine of theta. Now, if we integrate just this part here, because that's going to be on the outside, this is going to be from negative pi halves to pi times the negative sine of theta, and that actually comes out to just be 1. So E of the x direction is just going to be K times Q over pi halves R squared. And now for E of y, you actually get all the same stuff. Except this time, because it's in the y direction, we're going to have of theta. And so that's going to give us negative pi halves pi. Integrate that, it's going to be cosine of theta. And that actually gives you 1 as well. So you actually end up with the same equation here for both of them. So then to get the magnitude, you get our total. You'll have the square root of E of y squared plus E of x squared, which that will be equal to this K times Q over pi halves R squared, and then all of that's going to be squared plus AQ over pi halves R squared, and that's all squared, square rooted. We can add these together to get 2 times K Q over pi halves R squared, and then get that. And that's what your E of t is equal to. Now we can, that's squared, sorry. So we can kind of simplify that a little bit. That can go away, and that's still square rooted. This 2 can come up. So we can actually get an answer of 2 times the square root of 2 times K Q over pi R squared. And that's our final answer.